Have you ever noticed how clocks just keep ticking whether you're watching or not? Day turns into night. You grow older. Planets spin. Stars shine. Galaxies slowly drift apart. It all feels automatic, as if the universe is following some silent rhythm. Something constant. Something eternal. But what if it isn't? Just because something seems permanent doesn't mean it is. Time, motion, energy, these things feel infinite. But they're not. They're temporary. Like everything else in nature, they change. They decay. They end. And if we peer far enough ahead, not years, not centuries, but trillions upon trillions of years, things begin to fall apart in ways that defy our common sense. Not in a poetic or metaphorical way, but in a literal breakdown of the laws of physics. This isn't science fiction. It's not some fringe theory. It's where mainstream physics leads when we ask one haunting question: how does the universe end? The answer isn't just a slow fade into blackness. It's a strange transformation. A future where the rules we thought were unshakable begin to unravel. A cold, silent cosmos that becomes deeply unfamiliar, not because we imagine new laws, but because we followed the old ones all the way to their final, unsettling destination. So let's go there, not to the Big Bang, not to today, but to the very end. A time when stars are gone, galaxies have vanished, and even the atoms have nothing left to say. Have you ever watched a fire go out? First the flames weaken, then flicker, then finally, nothing. That's what happens to stars. They burn bright, they live wild, and then they die slowly, violently, magnificently. Our sun, for example, won't explode in a fiery supernova. It'll swell into a red giant, swallowing Mercury, Venus, maybe even Earth. And then, quietly, it will shed its outer layers like a snake shedding its skin, revealing a white-hot core, a white dwarf. That tiny remnant Earth-sized, but with the mass of the sun, will just sit there, glowing dimly. Other stars aren't so gentle. The massive ones collapse under their own weight, triggering cataclysmic supernovas. What's left behind are neutron stars unimaginably dense, or black holes, which are gravity's final form. The dead stars become cosmic tombstones scattered across space. As billions of years pass, fewer and fewer stars are born. Galaxies dim, light becomes rare, and the universe begins its long, cold goodbye. Eventually, black holes will be the last giants left standing. Not stars, not galaxies, just gravity. These beasts, once birthed from the collapse of massive stars or the mergers of galaxies, grow hungrier with time. They devour stars, gas clouds, even other black holes, dragging matter past the point of no return. But even black holes don't last forever. Thanks to a strange phenomenon known as Hawking radiation, they begin to evaporate extremely slowly at first, leaking tiny particles into space. Over unimaginable timescales, trillions upon trillions of years, they shrink. One by one, they vanish in a final spark of radiation. And when the last black hole dies, nothing massive is left. The universe is no longer a place of stars and fire. It becomes a graveyard ruled by cold, empty space. With the stars gone and black holes extinct, all that's left are the faint echoes of what once was. White dwarfs, neutron stars, maybe some rogue planets drifting through the void. Everything is cold, dark, and isolated. The universe is quiet, not peaceful, but eerie. In this degenerate era, change becomes excruciatingly slow. White dwarfs, over quintillions of years, cool into black dwarfs, frozen husks radiating nothing. Occasionally, two of them might collide, releasing a brief flicker of light, a rare heartbeat in an otherwise lifeless cosmos. But even these are rare. Eventually, radioactivity dies out. Chemistry stops. There are no more reactions, no more light. The universe becomes a frozen museum of what used to be. But wait, even the particles themselves aren't safe. Protons, the building blocks of atoms, may not last forever. According to some theories, they decay, very slowly. But they do decay, And when they do, atoms fall apart. Iron, the most stable element in the universe, will crumble. Everything that was once matter, planets, stars, people, even the remnants of black dwarfs will unravel into radiation and particles too weak to form anything solid. It's not a bang. It's not even a whimper. It's the quietest, loneliest kind of death. Dissolution. The physical universe dissolves, not with fire, but with silence. And then, there's the wildcard. What if, right now, we're living in a lie, a false vacuum? The Higgs field, which gives particles their mass, may not be stable. If that's true, it could suddenly collapse, triggering a vacuum decay. This collapse would create a bubble of true vacuum, traveling at the speed of light, destroying everything in its path. Physics as we know it would stop working. Particles would lose their identity. Atoms wouldn't form. The laws of nature would be rewritten. And here's the terrifying part. We wouldn't see it coming. No warning, just gone. In one instant, the entire universe could be rewritten or erased. Not in billions of years, but today or tomorrow. It's the most chilling reminder that even the deepest laws of nature might not be set in stone. Imagine everything, every law of physics, every stable reality sitting precariously on a cosmic fault line. We call it the Higgs field. It's what gives particles their mass. But what if this field isn't in its true resting state? What if it's only temporarily stable, like a marble stuck in a shallow dip at the top of a hill? This is vacuum decay, a terrifying idea that the universe is metastable, and someday, somewhere, a random quantum event could kick the marble over the edge. It would trigger a bubble of true vacuum expanding at the speed of light, rewriting the laws of physics as it passes through everything. It wouldn't hurt. You wouldn't see it coming. It would simply be over. One instant, there's order. The next silence, rewritten. A clean slate, where nothing familiar can exist. It sounds like science fiction, but it's real physics. Our universe, as stable as it feels, may be living on borrowed time. If vacuum decay doesn't end at all, the universe enters an era even stranger where logic gives way to randomness. Time stretches so long that even black holes are gone. Protons are a myth, and all that remains is a cold, thin mist of particles. But the quantum world isn't finished. Even in the vacuum of space, energy flickers in and out of existence. This is the quantum foam-the chaotic buzz of nothingness. Over unthinkable timescales, it starts doing something bizarre. Random fluctuations generate entire particles, maybe even entire atoms, maybe, eventually, entire brains. Yes, Boltzmann brains disembodied observers, popping into existence by sheer quantum chance. For a brief moment, they might think they're you, watching a video, reading a thought, living a life. Then they vanish. In a cold, dead void, reality is no longer structured. It's weird, fractured, and fundamentally random. The universe is no longer a place. It's a lottery of probability. By now, the heat death is complete. The cosmos has no gradients, no activity, just maximum entropy. In simple terms, everything is the same, everywhere, forever. But something even deeper is lost information. In physics, information is the identity of particles, the blueprint of what once was. And black holes, which once consumed matter, were suspected to erase that information. But quantum theory rebels against this. So, what happens? Maybe the information is encoded in the subtle glow of Hawking radiation. Maybe it's scrambled but still there. Or maybe it's truly lost. If it is, it means something profound. Time is broken, because time, at its core, is change. If information can't be traced, if cause is no longer linked to effects, then the arrow of time shatters. We aren't just facing the end of stars. We're watching the death of causality itself. Even in a dead universe, hope flickers. Quantum fluctuations might eventually birth another Big Bang. Or maybe this isn't the first time the cosmos has expanded and collapsed. Maybe we're in an eternal cycle, A big bounce. A cosmic inhale and exhale across infinities. Or perhaps there are other universes right now, budding off from ours through a process called eternal inflation, where bubble universes form endlessly, each with its own laws and constants. In this view, our universe isn't the story. It's one chapter in a library without end. Maybe, in some unimaginable future, intelligent life could harness quantum fields or manipulate vacuum energy, not to survive this universe, but to create a new one. A designer cosmos with fresh rules crafted not by accident, but intention. Could the universe be reborn? Maybe it already has been, 1,000,000 times before. And through all of this, through entropy, quantum decay, black holes, and frozen silence, the strangest fact remains. We're here, thinking about it. For all its scale and silence, the universe produced something that can question it. A conscious mind, a sense of time, a longing for meaning. We measure distant galaxies and speculate on dark energy. We try to peer into time before time. But the biggest mystery may not be outside use, it may be the simple fact that we care to ask at all. The end of the universe is vast, inevitable, and indifferent. But the fact that you're here, listening, wondering, reaching, maybe that's the real miracle.